So let's add a really basic feature is actually aiming, and aiming down sights, that is. So let's go into our controller, and we're going to give it, let's see, we're going to go over here and we're going to say public bool is ADS, aiming down sights. So how do we know if we are in ADS? Then inside our input, handle input, where we're doing all of this, we're going to be saying is ADS equals input get mouse button 1. So we have the right click. Now a few things that change when we have the ADS, but first of all we need to say handle weapon ADS. Okay, we're going to be passing the delta. So one thing that we need to change, we have the weapon parent, we're going to use the weapon actual transform for the sway. Okay, so let's go under the weapon, handle weapon sway, over here and over here. You'll see why. So weapon actual transform. Okay, on the ADS, if, well, we're going to be changing the local position, and that will be vector3 target position of the ADS will be vector3.0. So if you're not aiming, or if you're aiming on the ADS, well, I'm going to show you one thing. I'm going to say that, well, actually let's write it, and we're going to say that your weapon parent dot transform dot local position equals vector3 dot lerp it's already a transform, local position, target position, and all that by delta by 0.1. Of course it's super fast, it's meant to be. So here's one thing to know. Let's drop this inside our update after handle input. Pass the delta. So we need to know now the ADS position of each weapon, because I'm setting it up as if you're not aiming, we're going to find heap position. Okay, for now we could just say vector3 dot up taf p. Well, actually let's just do taf p dot x equals 1, taf p dot y equals minus 0.5f, whatever, something like that. Okay, if you're not aiming down sights. So the real trick is the weapons should be on the ADS, so they should be on this position once we want them on the ADS. Okay, well, apart from the Z. So here's what I'm going to do. I'm going to create a new empty object, which I'm going to call test weapon pivot. I'm going to parent this below. The test weapon pivot now is what we're going to be using to do the weapon sway. So I'm going to parent that in the weapon actual transform. And to find the actual center on my canvas, I'm going to create a new image. It will go right onto the center, and I'm going to make it a width of 1 by 1. Let's make it a red line. Let's change the width maybe a little bit more. Let's maybe make it something that we can actually see. Let's make it 5 by 5. Okay, then I'm going to, with a test weapon pivot at the very center, I'm going to go on the model itself and find the correct position for the ADS. And that should probably be minus 0.01. No. Minus 0.1. 909. I think 09 is fine. Maybe 0.8. I think 88. Yeah, 88. Minus 0.88 is fine. So this is now my ADS. So when I'm in the ADS position, it's going to give me this. Of course, we can play with the camera. We can have the field of view going inwards a little bit. So when it's not on the ADS, it's going to be placed on that position, on this position we now overwritten. But when I'm logging in, you see we are in the ADS. Now there is the weapon sway. So we don't want any weapon sway, of course. When we don't want any weapon sway when we are aiming, because it gets too frantic. So let's save the hip position onto the actual weapon itself. So over here we're going to say public vector3 hip position. Then in the controller, target position, that will be current weapon, base item, hip. I thought it was, yeah, base item dot weapon in it. It's current weapon dot weapon dot hip position. Okay, now we know that this is at vector3.0, so we only need to find one position, and let's try and place it. Something like that. That should do it, I believe. So that will be 0.19 minus 0.09. Let's find our test weapon. Minus 0.909 and 0.19, I believe. Yeah. Okay, let's hit play. Okay, so there it is. And when we're aiming, we just need to disable the weapon sway. Awesome. So, and let's find it. Weapon sway by factor x. But if is aiming, is ADS, target position, multiply that by 0. So that means we're doing, or well, we don't need to multiply it, we just need to set this up to vector3.0. So it doesn't really do anything. The same with I think the rotation we can keep it. Let's see. So it leaves a little bit of movement over there. I think we can keep that. Yeah, that does it. But maybe no, it's the rotation that makes it. Yeah, we don't want rotation, at least on the X and on the Y. On the Z we don't need any rotation. On the Y we can keep it, so let's do target tilted X multiplied by, so if is ADS, set that to 0, and target tilt dot Z equals to 0 as well. So he's just going to move it left and right. Okay, and the other question is, I think, yeah, it's coming from the footsteps. That's why. So we need to take care of the footstep as well when you are in the ADS. Let's see. There we have our footsteps, handle footsteps is moving, cycle position. Then, if that's the case, the multiplier needs to be considered differently. So I'm going to do float y position, or actually let's save that. I'm going to save public float, or not public, float footstep y position, and for that we will be doing a mathf.lerp of the footstep y by footstep y position to the target value position. So that will be float target value, where it will take all of this and paste it over here to the target value, and all that by delta minus 0.1f, and footstep y position will be this. But if is on the ADS, then that target value is going to be 0 because we don't want to be moving. Okay, maybe we do want to be moving it up and down, but definitely with some very small multiplication. So maybe let's just say public float ADS multiplier. Yeah, ADS multiplier, but then that will mean we need to change this. So let's take this down here. Let's say that, oops, target value, let's make this target multiplier. It will always start with the footstep multiplier, but if it's that, then it will be the ADS. Then that will be the cycle position by the target multiplier. Okay, then let's check the ADS. Okay, and I'm just going to use 0.0003. The reason why we're going that slow is because we are talking about very tiny amounts of movement. Okay, and there we go. So if I'm start moving now, you can see it. We now have proper ADS. That's perfect. Perfect. So one more thing that we can do, we can actually control how much ADS on the FOV of the camera is giving us based on the weapon itself. So if you have a sniper rifle or something like that, you can change that in here. So we can say ADS FOV, and let's go. Let's set this to 30, and then in the controller we will do, let's see, where do we have the handle ADS over here. Then we will do float FOV equals current. Yeah, we need a reference to a camera for this. Exactly, the camera. So that will give us camera. Then on start we could say camera equals camera transform. Let me see. So that will be camera transform dot get component in children camera. Okay. Then let's go on the handle ADS FOV camera transform dot FOV camera dot FOV what's the focal length? Yeah, whatever. Let's put this over here. If it's not yeah, no. If it's not ADS, this needs to be in here. Then if it is ADS, current weapon ADS FOV. Okay. And this might break a little bit if you want to have FOV settings. So for that case, we will do this as a negative value. So that will mean we're going to get the base value of, or the standard value of our FOV. Ours is now 40 minus the ADS FOV. So I'm just going to say just minus 5. Then we're going to do on our FOV, on our weapon, no, on our camera field of view, mathf dot lerp between camera field of view and the target FOV you have. All that by delta pi upon 1f. So we're going to have now different FOVs as well. Okay, one problem, I think we need to store the save. Yeah, we need to store the starting FOV somewhere. So starting FOV will be after we have our camera dot field of view. Perfect. Then in the ADS, this will be the starting FOV, but with that we can also say starting FOV minus ADS FOV, and that will do it. We should be able to go back and forth now between our FOVs. And another thing we can do with our crosshair now is that we can add, well, we can certainly remove the dot on the center first of all. Well, we're going to need it for other weapons, so let's keep it for now. Just going to disable it. Then on our crosshair we have a canvas group, as you can see, so we can assign on the canvas group. Let's take it, canvas group, get component, canvas group. Then inside update, if controller, or let's say float, float alpha equals to 1 if controller dot ADS or is in ADS alpha will be 0, then canvas group dot alpha equals mathf dot lerp canvas group dot alpha well, that by time. As you can see, we do use more than once delta time, so that will mean we need to pass the delta like this. By delta, let's make it by 0.2 f. Yeah, That will do it. So minimize that, and you will see just like this. We will be able to basically just fade in and out our crosshair. Perfect. Then crosshair, let's see. Maybe we can make it a little bit faster. So let's maybe make it 0.5 f. So it doesn't ease in and out. Yeah, that's better. That's more fancy. Now I think we need to change a little bit the base height of our camera. That's of course for my taste. So let's maybe make it 1.3. That's 1 meter. That's 2 meters. Normally you go with, let's say, you're close. We had it at 1.4. No, I think 1.4 is fine. If we are not moved at all, when we hit play, it should be fine. Let's see. Yeah, we are being moved. So the center is, I think what moves us is the steps offset. Let's set that to 0 and leave that. No, it's not then. 0.3 height. Let's say, now how much will that distance be? Let's say 1.2, 1.1. I think it's 0.1. Let's say if it moves us even more, it moves us down. So it's half of that then. 0.5. So on my pivot, I'm going to go with 3. Let's try 3. It's not just the height of the player, it's the fact that you also need to take into account that he's not, standing still. He's moving away. Now, one last thing is that, of course, the all common problem of the guns clipping through the levels. That's always a problem. So how do we fix that? Very easy. We create a second camera and we parent it underneath our weapon parent. They are the same position as the other one. Okay, this will be the gun camera. Then we're going to create a new layer which we're going to call FPS. This camera will not render FPS, but this one will render nothing but FPS, and we only need to render depth. Okay, so this is now the gun camera, which only renders FPS. We don't have anything yet on the FPS layer, so we just need to change the layer of our weapons to our weapon. So if I close this now, you'll see I'm losing my weapon because it's rendered on the FPS camera. So this way, what did we forgot? We forgot that we are moving this camera, so this camera needs to be inside the head as well, not inside the weapon parent, because the weapon parent moves around. Come on, what am I doing? Let's see, calling mask FPS. Where is it? Test weapon FPS, gun camera. Let's make this depth of 1 first of all. So it's rendered on top of the other camera. Okay, and there we go. And you cannot really clip through the camera. because it's rendered on a layer above. That's perfect. So now we have our FPS with some actual weapons and stuff like that. We can also run. Of course, we need some animations to do that, but you can see that it looks pretty fine. So that's it. Let's save, and that's it for this part as well. As always, you know what to do. Like, subscribe, and if you like to see more stuff, more videos, more series, more of everything, then of course consider supporting me on Patreon so we can keep making all of these nice things we're making. I'll see you next time.